Today we are going to learn about the Riemann sums. Riemann sums is to evaluate an integral. But first thing first, we must assume that the function f was continuous and non-negative over the interval close a and b, which means that f is integrable on close a and b. So here is the formula. Integrate from a to b of the function fx dx equals to the limit n approaching infinity. Sum of I equals to n 1 and n with fxi times with the delta x. This one is to calculate the total area of rectangle. Measurement that the fxi is the length and the delta x is the width. So times 13 to get the total of area of rectangle. We use the limit n approaching infinity because there's many rectangles. So that's why we use the limit. So to use the Riemann sums, we must know the steps. There are 4 steps. 4 steps to use the formula. So the first step is to calculate the delta x. The delta x is equal to b minus a over n. B is the upper limit and A is the lower limit. Then the second step is to find the xi. Xi is equal to A plus I delta x. The third step is evaluate the fxi. Then the fourth step is to use the limit laws to simplify. Limit laws, this one. Then the last step is to use the sum laws. Okay, so we start with the simple function. Integrate from 0 to 2 of x dx. So first we must find the delta x. The delta x equals to b minus a over n. So we know that from this function, we know that p equals to 2 and a equals to 0. So 2 minus 0 over n equals 2 over n. So the first step is done, and the second step is we must find the xi. To find the xi, if xy is equal to a plus I times with delta x. So equal a is 0 plus I, the delta x we know that 2 over n. So the xy is 2 over n I. Okay, the second step is done, and move to the third step. Okay, the third step is to evaluate the fxi. Okay. So first, for example, fx equal to x, so the fxi is equal to 2 over n I. Okay, so the third step is done, and now we move with the fourth step. Fourth step is use the limit laws to simplify. Okay, integrate from 0 to 2 of x dx equals to the limit and approaching infinity, sum of I equals to 1 and n with fxi times with delta x. So limits and approaching infinity, sum of I over sum of I equals to 1 and the fx, we know that the fxi value is 2 over n I times with the delta x is 2 over n. Okay, so limits and approaching infinity, sum of I equals to 1 and 2 over n times with 2 over n is equal to 4 over n squared I. So then limit and approaching infinity, we're taking out the 4 over n squared to the outside from the sum of I equals to 1 and I. So we move on with the 5th step. The step 5 is sums. For the sum, we must know the sum of I equals to 1 and I is equal with n times with n plus 1 over 2. But the sum of I equals to 1 and with n, I squared equals to n times with n plus 1 times with 2n plus 1, the whole thing's over with 6. Then for the sum of I equals to 1 and n with n, I cube equals to n times with n plus 1 over 2, and this whole thing is squared. Okay, so limit and approach infinity, 4 over n squared times with n plus 1 over 2. So this one is 2, 1 n squared, it means 2. So for this one, in case you don't know this one, right? 2 over n squared times with n plus 1 over 1. Over 1, so just ignore the over 1. So just ignore this one and you can continue. So, and 2 over n plus 1 means that 2n over n and n, so 2. Yeah, in case you don't know, I explain why we got 2 from here to here. Okay, just explain it. in case you don't know. I don't expect you to know about this, but if you don't know, so you don't know lah. You don't know, you try to understand this lah. Okay, transform it by integrate 0 from 2 of x dx goes to x squared over 2 from 0 to 2. Then we substitute the x with 2 squared over 2 minus 0 squared over 2. Then this is 0. We get 4 over 2. 4 over 2 is 2, which means that the answer is same, and we are right. So that's all.